Okay, just a quick run through of the paper going over all the major topics. Let's start with the tree diagram. Probability that both discs are red, obviously because they're not being replaced, you go from having 3 out of 5 that are red and 2 out of 5 that are blue to having 4 left. If you take a red out, there used to be 3 red, 2 blue. If you lose a red, there's now 2 red, 2 blue. So those are the probabilities there. If you take a blue out, then instead of having 3 red, 2 blue, you're going to have 3 red, 1 blue. So the probability, having taken a blue out, that the next one is red is 3 out of 4, and the probability of having taken a blue out, the next one is red is 3 out of 4, and having taken a blue out, it's 1 out of 4 for the second one. So both discs are red. It means the first one's red and the second one's red. And you go on long branches, you multiply. So 3/5 of the time you're going to get a red, and then 2/4 or a half of those times you're going to get a red again. So that's 6/20, which cancels down to 3/10. For 1 red and 1 blue, obviously the first one can be red and the second one can be blue, or the first one can be blue and the second one can be red. Watch out, because there's 2 different ways of doing it. So red times blue is 3 times 2 over 5 times 4, which is, again, 6/20, 3/10. And it's the same calculation again, because the numbers on the top have just changed places and the numbers on the bottom haven't changed. So it's 6/20 plus 6/20, which comes out as 3/5. Any equivalent fraction is fine, 6/10 or 12/20. At least 1 blue disc. Whenever you see the phrase at least 1, you have to think, what's the opposite of at least 1? If you say, I have at least 1 sports car at home, what's the opposite statement? Well, either you have at least 1 sports car or you have no sports cars. The opposite of at least 1 is none. So the easiest way to work out the probability of having at least 1 blue disc is to work out the probability of having no blue discs, i.e. both discs are red, and it'll be 1 minus that. The other way to do it is to work out all the different ways that you could have at least 1 blue disc, which would be to have red, blue, blue, red, blue, blue, and then add them together. Perfectly acceptable, but it just takes longer. If we carry on, the probability that 3 red discs are selected, you could do this without a T diagram and say, well, 3 out of 5 are red to begin with, then 2 out of 4, and then 1 out of 3. So it's just those multiplied together, which comes out as 1/10, I think. The other way to do it is to extend it on the diagram and say red, red, and then red again. You don't need to actually draw the blue branch if you don't need it. So you can just go through the logic, 3 out of 5, 2 out of 4, 1 out of 3. But just because you're doing 3 times doesn't mean you have to draw all the branches at this point, because you don't need them all. Similarly, 3 blue discs are selected. We can just do this without the tree diagram. Well, in fact, it's kind of obvious, because if there's only 2 to begin with, then you can't take 3 out, so the probability is just 0. Next page. James, upper bound. Okay. If it's to the nearest centimetre, then hopefully you know that for bounds you go to the next centimetre, up and down, and then halfway between them. So if 30 is the centimetres measured to, next one down would be 29, so halfway to that is 29.5. Next one up is 31, so halfway to that is 30.5. And similarly for the lower bound, 6.5 and 7.5. When it asks for the greatest area of paper left after he's removed the circle, you're starting with a sheet of paper and you're cutting out a circle. So if you want to have the most amount of paper left, then you want the biggest paper to start with and you want the smallest circle. So to take to the biggest piece of paper to start with, the biggest piece of paper to start with, then you want the square piece of paper to be as large as possible. So if these measurements are only correct to the nearest centimetre, it could be anywhere between 29.5 and 30.5. So to make it as big as possible, you're going to go for the biggest possible measurements for the piece of paper, and that'll be your starting area. And then the smallest possible measurement for your circle, so it'll be pi r squared, so pi times 6.5 squared. And then big paper minus small circle gives you your answer. I don't know what it is. I can try and do this quickly, so I'll move on. Rearrange to make k the subject of the formula. Because k appears twice, you need to get all the k terms on one side, all the not k terms on the other. So I'm going to move this ak across, I'm going to move this p across. So we get k minus ak equals p. Once you've got all the k terms on one side, you factorise to turn 2 k's into 1, and then you divide that factor across. Sketches of the graphs. Gradient is 4, intercept is -1, so it looks like that. 1 over x, you just need to know this, it looks like that, because When x gets very big, 1 over x gets very small. When x gets very small, 1 over x gets very big. And the same happens, but negative on this side. So it gets closer and closer to the axes without it touching, which means you have asymptotes here. Those are lines that the graph never approaches but never meets. Again, use your calculator to get these values. What have we got here? 2x squared, so it's 11 minus 7 minus 3. Oh, I can't work this out. Anyway, you're going to get a quadratic. We've done this in class, sorry, I'm kind of rushing through this. To solve where it equals 0, it's where it goes through the line y equals 0, so it's where it crosses the x-axis. To solve this equation, your graph is 2x squared minus 3x minus 5. And when you're solving these equations, which are different to the ones in your graph, it's always question to graph. So as you go from the question to the graph, this is the same, this is the same. Minus 2 to minus 5 means you've gone down 3. So you draw the line y equals minus 3. And the x values where that crosses into your curve, those are the solutions. Similarly for here, it's different to the graph, so write the graph underneath. How do we get from the question to the graph? We've gone from minus x to minus 3x, so that's minus 2x, and we've gone from minus 15 to minus 5, so that's plus 10. So we go to 10, and looking at the scale, it's a bit weird, but it's a gradient of minus 2, so it goes down 2 every time you go across 1. So across 1 is 2 big squares here, and then down 2, 1, 2, like that, like that, like that. You can plug these into your calculator as well. You could just plug in y equals minus 2x plus 10 into your calculator and it'll plot it for you. And you get that line, sorry that's a bit rubbish, but you get the idea. And wherever it crosses your curve again, that's the answers. Moving on. The modal class is the most popular group, so it's the one with the highest frequency. So that's the highest frequency, so it's 16 to 18. Estimate the mean. You're estimating the mean because you haven't been told what exactly the heights of the plants are. You're just told they're somewhere between 8 and 10, 10 and 12, 12 and 14, etc. So you pick the middle point and you say the average of this group is going to be 9. So it could be both 8, it could be both 10. We'll assume that those two plants have an average height of 9. So their total height is going to be 9 times 2. The next one's going to be 11 times 0. The next one, the total height is going to be 13 times 3. And you add all those values up, blah, 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 and you divide by how many plants there are, and it's 60 plants. You could work that out by adding up the frequencies, and that will give you the mean height. The median, if there's 60 plants, that means that the middle plant is half of 61. You add 1 to the number of numbers and then divide it by 2. So the middle is actually in the 30.5 position. But because it's group data, you can ignore the adding a half and just say it's roughly the 30th position. Either way, it doesn't make any difference. To work out where the 30.5th one is, we know the first 2 are here. We know the next 3 are here, so that's the first 5 plants accounted for. We know the next 18 are here, so that's the first 23 accounted for, and the next 20 here, so that's the first 43. Now, if there are 23 plants in the first 4 of these categories, and then there's 43 plants in the first 5, that means that the 30th and the 31st are both in this group, and so it's 16 to 18. So that's the class where the median lies. If you wanted to work it out more accurately, you'd do a cumulative frequency plot with this stuff. Factorizing. Right. This one, there are common terms. 6 and 9 both have a common factor, 3. A squared and A squared both have a common factor, A squared. B and B squared have a common factor, B. And no C and C do not have a common factor. If C only appears in one of them, it's not a common factor. So you take all the common factors out, and then you just work out what you have to multiply this by to get each term. So 3, what do you multiply it to get? 6. What do you multiply A squared to get A squared? 1, you don't need to write that. What do you multiply B by to get B? 1 again, so that's it. What do you multiply 3 by to get 9? What do you multiply A squared by to get A squared? What do you multiply B by to get B squared? What do you multiply nothing by to get C? And that's it, done. This is a tricky one. There are no common factors here. Well, actually, no, I lie. There is a common factor first, so let's work that out. 25 goes into both of these. So it's 25 f squared minus 4. And then this, there are no common factors here, so it might look like you can't factorize this any further, but of course it's something squared minus something squared. It's the difference of 2 squares, so this is 25f plus 2, f minus 2. Most people would get this wrong. It's quite a difficult one. This is a classic quadratic. Multiplies to make minus 12, adds to make minus 1. It's g minus 4g plus 3. Simplifying, 14 over 21, if you don't know how that cancels, type in 14 over 21 in your calculator and it'll tell you it's 2/3. There's x squared here, there's x here, which means there's one more x on top. There's y here, there's y squared here, which means there's one more y on the bottom. If you're adding fractions, or subtracting, adding and subtracting, either way you've got to have a common denominator. And these don't have any factors in common, so the only way you can do it is by multiplying them together. Sorry, it's a plus 1, a plus 2. When you're converting fractions into a new denominator, whatever you multiply the bottom of the fraction by, you have to multiply the top as well. So 1 over a plus 1, a plus 1 at the bottom has gone from a plus 1 to being a plus 1 times a plus 2, so which means you've got to multiply the top by a plus 2. Similarly, you've multiplied this by a plus 1 to get a plus 1, a plus 2, so it means you've got to multiply the top by a plus 1. If you do a plus 2, careful here, minus brackets a plus 1. I'm putting the brackets on because, remembering Hitler's Tash, you're minusing all of that. So minus brackets a plus 1. When you lose the brackets, it will be a plus 2 minus a minus 1. Bit nasty that, over a plus 2, a plus 1. And so the top simplifies to just 1 over a plus 2, a plus 1. For these last ones, x to the minus 3 is 1 over x cubed. Is that true? Well, minus means flip it, so it means takes x cubed and flip it. Sorry, you can't really see the minus in this video, unless it's on HD. So that is true. X squared plus x cubed equals x to the 5. Well, x squared is x times x, and x cubed is x times x times x. If you add them together, you don't get x times x times x times x times x, because it's x squared plus x cubed. So x times x plus x times x times x is not the same as x times x times x times x times x. So that's not true. X to the half equals root x. That is true, because remember, when you multiply powers, you add them. So x to the half times x to the half, if you add those together, must be x to the 1. And so if x to the 1 is x, and x to the half is something that you multiply by itself to make x, then it must be the square root. So that's true. X to the minus 2 does not equal minus x to 2, because we already looked at what minus powers do. And then x to the 0 is 1, because anything to the power 0 is 1. I could explain that more, but that's just something you need to remember. Oh God, is it 12 minutes already? Right, better split this.